Hi. Now, in this video, what I want to do is show you how we can go about drawing a polar equation of a curve. And I've selected this equation here, r equals 4 theta. And I'll also talk to you about how we draw this on polar graph paper. So when we're drawing a graph, what we do is we can form a table. Now, r must always be a positive value. So in order for the r to be a positive value, theta would have to be a positive value. And theta in this case can be anything greater than or equal to 0. Now I'm going to plot this graph for theta going between 0 and 2 pi radians. So we'll start then with theta equaling 0. And we've got to work out what the corresponding values of r would be. Now if I'm going up to 2 pi, I need to set an interval, and it's totally up to you what kind of interval you take. But I'm going to take the equivalent of 45 degrees, which would be pi upon 4 radians. So if we go up in intervals of pi upon 4 radians, the next one is going to be pi upon 2, and then would have 3 pi upon 4 radians, 3/4 pi, and then pi radians. I'll also need to just extend this because I haven't got enough room here. So we'll just carry on then. We've got theta and r. So after pi radians, if I add another pi upon 4 radians, that's going to be 5 pi upon 4. And then you've got 3 pi upon 2. And then 7 pi upon 4, and then 2 pi. Okay? So, when theta equals 0, if we substitute it in here, 4 times 0 just gives us 0. But pi upon 4 in here, 4 times pi upon 4 is going to give me pi. And 4 times pi upon 2 is 2 pi. And you'll see that if you work these out, you get 3 pi, 4 pi, and it just keeps going up in intervals of pi. Okay, 6 pi, 7 pi, and 8 pi. So we have our corresponding values of r for various values of theta. Now we need to plot these values on this graph here, this polar graph paper. And what we've got here is the initial line where theta equals 0. And we've got our pole here, and you'll see all these concentric circles. Now these concentric circles give us a scale that we can use for r, and in this particular question we've got r going from 0 to 8 pi. So what I would suggest is that we take this outer ring here as representing 8 pi. And that would mean that each one of these intervals, okay, would represent pi units. We'll put the scale on. Now when it comes to plotting the points, if we take the first point here, it's at the origin, the pole, 0, 0. Theta equals 0, and we're at this point here, r is 0. Then we go to theta equaling pi upon 4, and we see that r is pi. Now for theta being pi upon 4, that's going to be along this line here, the equivalent of 45 degrees, and r is pi. That's on this inner circle here, so we've got a point here. For the next one, theta equals pi upon 2, and r is 2 pi. So theta equaling pi upon 2 takes us on this line here. But r has got to be 2 pi, so we're looking at this circle around here. So it's this point. And if we keep this up, we've got 3 pi upon 4 for theta, and r is 3 pi. So 3 pi upon 4 is on this line, and 3 pi is on this circle. So we're here. Now if you put the other points in, you can check them out. You're going to get them coming out like this. Okay? And what we can then end up doing is just joining them all up, and what you'll see we get is a spiral. So in general, if r equals a constant, let's call it a, and it's multiplied by theta, where that constant a is greater than 0, what we generate is a spiral. Now, this is one of many common curves that we're going to be looking at, and I hope it's given you basically a start then on how we draw these curves on polar graph paper, and that you'll use this anyway as a basis for further curves.